part involves f inverse f. So when you see f inverse f or when you see f inverse, okay, these are composite functions. Okay, now they are all going to give you the same result, but the domain is different, so the function is actually different. I'm going to show you in this example over here. But before that, if I want to remove, for example, this is a composite function g f x and it's equals to a certain value. If I want to remove g from this side, I can only remove the most outer one. Okay, first I introduce g inverse on both sides, g inverse here and g inverse here. So when you have g inverse, is going to be gone. So they are going to left with fx equals to g inverse a. So this is how we remove a certain function on one side, by introducing its inverse on both sides. Okay, so next is, now it is given that f is a 1, 1 function. So remember, inverse can only exist if f is a 1, 1 function, given by this. So first thing, I will always write down y equals to, fx equals to 2x plus 3, and I'm going to write down the domain is inclusive of -2 to 2. Now I want to find f inverse, so let's recall. In order to find f inverse, I let y equals to 2x plus 3. So I have x equals to y minus 3 over 2. Therefore, my f inverse x is going to be equals to x minus 3 over 2. Remember, we have to write the domain first. You can key into your GC, or you have to know all straight lines. So this guy is a straight line. In your mind, you can have this straight line that is going upwards over here. Y-intercept is 3. What is this point? When x is 2, y is going to be 2, 7. Okay, and over here, when x is -2, y is going to be -1. Also, I know that the range of f is equals to include -1 to 7. So that's why my domain of f inverse, it depends on the range of f. I can say my x is in between -1 to 7 inclusive as well. Okay, so this is what the first part of the question wants you to find. Part 2, whenever you see f inverse f x, okay, this just means x only. F inverse f, because they are going to negate each other, you are just going to be left with f x. But what is the domain of f inverse? Again, f inverse f is a composite function. Domain of f inverse f depends on the domain of f. So in this case, we are talking about x is from -2 to 2. You can represent it another way, it doesn't matter. Okay, so the domain of f inverse f is going to be equals to x, where x is from -2 to 2. But if we are talking about f inverse x, again, f inverse negate each other, it will be gone. You will still get x, but the domain of f inverse depends on the domain of f inverse. And what is the domain of f inverse? From the top, you saw, it's over here. It's from -1 to 7. So I can say x is from -1 to 7. These two, even though the equations are the same, they are different functions just because their domain are different. Okay, just because their domain are different. So I need to sketch the first one, which I'm going to use blue. The second one, I'm going to use red in a graph. Okay, y equals to x is a straight line that passes through the origin. So for the first one, I am going to specify it as -2, 2 inclusive here, and I know that y equals to x means this is -2, -2. This is 2, 2 because y equals to x. Or draw a straight line, and then this is the graph of y equals to f inverse f. Okay. However, for the red one, the domain is from -1 to 7. So now I'm going to put -1 here, and then I'm going to put 7, which is quite far away. Okay. Well, when x is -1, it must lie on this line, lie on top of this line, and go beyond the 2 to here. So this will be -1, -1, and this will be 7, 7. Okay, so these are two different functions just because their domains are different. Okay, and the last part, the question is asking, oh, when is F inverse F equals to F of F inverse? Okay, let me see. Yeah, they say solve. Okay, so look at this part. This is like a inequalities. Where is the part that they overlap? So in this case, F inverse F is equals to F inverse when X is from -1 to 2. Okay, this is the part. Can see that they overlap each other. This is the part when they are equal. Okay, so you can say when they are equal, you can say that oh, F inverse F equals to X when this is the domain, or rather let's put it nicely, okay, it still equals to X, comma, or X is from -1 to 2, because this is the part that they overlap. Now usually in this kind of question, they will ask for what is the set of values. Okay, they will not ask you to solve, they will ask what is the set of values for which F inverse F is equals to F inverse. We are just going to say that X is any real number such that X belongs to -1 to 2. Okay, and this whole thing is a set, and this is the solution where, can you see these two graphs intersect each other? And this is the question. These are the questions we usually involve F inverse F and F inverse.